Hi everyone, this is Sai Teja from CSE Section B. Today my topic is about a new friend sort algorithm. It is nothing but sorting of algorithm. Sorting is a nothing but dividing the set of numbers into two groups is called as sorting. The algorithm is a nothing but set of rules to solve a program is called algorithm. Let's get into a topic. Introduction. Sorting algorithm and the sorting itself is an important concept in a computational field. In this research study, we are proposing a unique sorting algorithm based on assuming the first value as smallest and comparing it with the rest of the list, and assuming the last value as biggest and comparing it with the rest of the list. Running cost analysis and its results obtaining after implementation are provided in graphical form with an objective to compare the efficiency of a proposed technique with some existing well-known techniques of sorting. Sorting algorithm is nothing but we are dividing the two set group of list of numbers into two groups. As we know that if you want from the smallest to biggest, we have to so you have to choose the first value as the smallest and comparing it with the rest of the list of the values, so that we can assume the last value as the biggest. As comparing it with the rest of the list, we can divide the list into two equal parts. Algorithm. Algorithm has a vital and key role in solving the computational problems. Informally, an algorithm is a well-defined computational procedure that takes input and provides output. Algorithm is a tool or a sequence of steps to involve the computational problems. Known when sorting really is sorting is a organizing of data into a particular increasing or decreasing order. The algorithm is a sequence of steps to solve the computational problems in a sequence way, that is in ascending and descending order. Data can be in numerical or character form. There are a lot of sorting techniques currently used in industry and academic to arrange the data of various forms. Sorting algorithms. The study in hand purpose a new sorting technique that is tested analyzed against previous sorting techniques to provide its efficiency. Sorting is of considerable importance as a human in processing in keeping the order information or knowledge. To search the information efficiently, the range of data is very important. Sorting is the reorganizing of given items on the basis of well defined ordering rules. The computational problems always have a cumbersome effect on the researchers one hand and open the opportunities for them on the other hand. The ultimate intention of so much sorting techniques is to cost and complexity reduction of algorithms. The main intention of this sorting technique is the cost and complexity reduction of the algorithms while doing any solving any problems. There is a sort technique named as bubble sort. Bubble sort is a pioneer among all the sorting techniques. It is the simplest and popular one. In fact, the bubble sort is well known to all the educated students now educating students because as the coding in the coding part, the bubble sort is the very simplest and popular one in among all the sorting techniques. It takes a list, compare the two items at end and swaps them if they are not sorted. First of all, it takes the list and comparing the two items at a end and swaps. The very number will be in a disorder. It will swaps them, and if they are not sorted, they repeat the steps until one of them compared item reaches its exact location. First of all, it will take the first value and it will compared to the rest of the values in the list. If there is any if there is one of the compared item reaches its exact location, it checks the location of the each value. If it reaches the exact location, it will stay there. Otherwise, it will repeat the steps until the one of the compared item reaches its exact location. These all steps continue till no swapping is needed. It is the sorting technique will be repeated steps until the one of the compared item reaches its exact location. The whole steps continues till no swapping is and it this is the time when sorting is completed. After that, no sorting is needed. Then that is the time when the sorting is completed. We can finally conclude that there is no swapping, so we can conclude that sorting is completed. The name of this algorithm comes from the static, the smaller elements called bubble, to the top of the list. From the list of 100 items, bubble sort makes 10,000 comparisons to sort the list. It is 35 and inefficient as compared to today's sorting algorithms. If we have a sorted list and applied bubble sort, it shows a behavior of order of big O of n. The time complexity of bubble sort is big O of n, and the average and worst case of time complexity of bubble sort is order of n square. Cocktail sort is also known as shaker sort, a bidirectional bubble sort, or cocktail sort. This also refers to a variant of selection sort, triple sort, shutter sort, or happy horse sort. This is a variation of bubble sort that is both a stable sorting algorithm and a comparison sort. The cocktail sort is different from bubble sort as it sorts the list from both directions. Cocktail sort is a bit complex than bubble sort in implementation. It is simple in nature and solves the problem with turtles like a bubble sort. The average and worst case of time complexity of cocktail sort is equal to bubble sort, that is order of n square. Selection sort. Selection sort is another well-known sorting technique that scans the list or array to find the smallest item, puts it at the first location in the list or array, then scans the list for the second smallest item, puts it in the second location, then the third smallest, and so forth until it reaches the largest item in the last, putting it at least last location in the list. The selection sort is also a well-known to the sorting techniques. It first of all it scans the first list and it finds the smallest item. When it finds the smallest item, it will put it at the first location in the list. Then scans the list for the second item. As it compares to bubble sort, it will be the selecting. It will be selecting the smallest item and puts it in the exact location where it will be, and it will scan the next smallest item, then it will be until the largest item will put it at the last location of the list. The time complexity of this selection sort is order of n square. For large list, its performance is worse than of insertion sort. Insertion sort. Another renewed and simple technique of sorting is insertion sort. Insertion sort, an efficient sorting technique, selects one element in every pass and inserts it to the original location in a new list. It is highly efficient at a small list and is very simple and easy to implement. This insertion sort is also a simple technique of sorting. It is a efficient sorting technique. Selects one element in every pass and inserts it the exact original location in the new list. It is highly efficient on small list and is very simple and easy to implement. The worst case time complexity of insertion sort is also order of n square. The insertion sort algorithm is very slow algorithm when list is very large. There is a drawback in the insertion sort is when the list is very large. The insertions or algorithm is very slow algorithm when the list is large. If the list is very small, it will be very simple and easy to implement. If the list is very large, it is highly efficient to solve and implement the insertion sort. This is the one of the drawback of the insertion sort. And the other one is quicksort. Quicksort is another well-known sorting algorithm and based on divided and conquered paradigm. The quicksort is it mostly depends upon the divide and conquer. It will divide the list into two parts and conquered with it will compare list by slowly swapping the numbers from small to large values by changing its location. Its worst case running time is n square, having a list of n items. In spite of slow worst case running time, quicksort is often the best practical choice for sorting the list because it is extremely efficient on the average running time, that is n log n. In most real world data, it is possible to make design choices which minimize the probability of requiring quadratic time. Another one is the bucket sort or bin sort. Works by partitioning an array into a number of buckets. Each bucket is then sorted individually, either using a different sorting algorithm or by recursively applying the bucket sorting algorithm or bin sort algorithm. It is a cousin of a radix sort in the most to least significant digit flavor. Since bin sort is not a comparison sort, the time complexity of omega of n log n lower bound is inapplicable. The computational complexity estimates involve the number of buckets. Friend sort algorithm. Friend sort is based on the idea of a selection sort. It assumes the first item of the list as the smallest item, compared it with next items. If required, swap, then else compared it with the next item. Then assume the last item of the list as the biggest and compared it with the previous item of that list is same manner as in friend in the first one. So in first pass, two items in the list are in their exact position in the list. In this sorting algorithm, it assumes the first item of the list as the smallest item compared with the next item. If it requires swap, then else compared with the next item. Then assume the last item of the list as the biggest one and it compared with the previous item of that list. And if it requires swap, it will then else it will compare. The steps of the proposed friends sort algorithm are as follows. First one, take first element of the list and compare it with next element. If required, swap the two elements, else go to next step. If first of all, it will take the first element of the list as we given in the list. It will compare with the next element. Beside element, it will compare, and if there any if required the swap of the two elements, else it will swap, otherwise it will go to step 2. Take last element and compare it with the second last element if required swap two elements. And again it will go to last element, it will look that element if there is second last element, it will compare with the last previous element, and if there any required swap, it will swap, otherwise it will be swap the two elements. Okay. Iteratively compare the first and last element with the whole list and swap wherever required. By comparing the first and last element, the whole list will be swapped by looking or by comparing with each and every element. Increment the pointer and move to the next element and comparing it with the whole list. By incrementing from the first element, it will increment from first to and it will move to next element until it reaches the end of the list. It will compare and it will be, if there is any required of swap, it will swap. Otherwise, it will go to next element and it will check that until the list will be end. Conclusion. By analyzing the above, it can be easily examined that friend sort clearly efficient than some well-known sorts like bubble sort, cocktail sort, etc. Equally efficient with selection sort and insertion sort for the small data and less efficient for large data. Although it is less efficient than the most efficient algorithms like merge sort and quick sort, we are foreseeing to come up with a new sorting technique which hopefully will be more efficient. Overall, this analysis shows that friend sort is very efficient for small number items in a list, so it will show high efficiency for small list of up to n elements. Finally, we conclude that these sorting techniques are very efficient when the list has the small number of items. If the list is small number of items, it shows high efficiency for a smaller list up to n elements. As it as the list is larger, it faces some difficulties while sorting the list of the elements. These are the few sorting techniques we can among them few are we can use our daily life and daily life in our coding part. uh, some are some will help in the small number of list items. Some will be facing little difficult when we compare with large number of items in a list. In comparing to all complexity cases, there are as we compared, if the list is very small, the time complexity is very less as we compared. But when you see the list is large and the time complexity also requires more as we compared with other sorting techniques. Thank you all.